Hello, this is the encrypted malware traffic detection presentation for our group for our Spring 2022 Capstone project. The team members are Rima Alrube, Sabrina Ellison-Brown, Ashley Evans, Victor Okiriki, Santanu Podar, and Spencer Shaw. This is being presented by Sabrina Ellison-Brown on behalf of the group. The purpose of our project was to train a deep learning model to analyze encrypted network traffic and to use what it learned to detect malicious traffic within it without decrypting the network traffic first. Within our capstone, we had 4 deliverables and we completed all 4 of those. And one of our, or some of our group accomplishments that we are proud of is that all of our members were very professional in completing their tasks and in communication with each other. We met on time and as needed. We used Teams quite frequently to stay connected through the chat and through file sharing. And team members were always willing to help each other with tasks as was needed. So this is the dashboard of our deliverables. So you can see the completion status of each one. As I said earlier, we had 4. So our first deliverable was a literature survey of the research that exists about monitoring encrypted traffic and the characteristics and use of artificial intelligence. And this deliverable is complete. The second deliverable was the machine learning analysis that was done on our encrypted network traffic in order to learn to detect malicious traffic. So this deliverable is also complete. And our third one was writing a research report that consolidated all of the research we gathered during our literature survey and then combining it with the processes and the results of our machine learning analysis to form a research report. And this is also complete. Our final deliverable was a web-based interface that would allow a user to choose the data file that they want and visualize the results from a machine learning model being run on it. This one we had some difficulty with, but we have ultimately been able to complete this deliverable also. So our research for deliverable 1 was aimed to answer and address the areas of knowledge that are here. So what is machine learning? What are the major steps for applying machine learning? What is encrypted malware, malicious traffic monitoring, and why is it important to monitor that? How existing works apply machine learning to the problems above? And what is deep learning? What's the difference between machine learning and deep learning? And what's the advantages of deep learning over conventional machine learning methods? So encrypted traffic is a good process for users' data. It protects them, it protects it from unauthorized access, protects their privacy, but it also has started to provide some challenges. We're finding that almost 92% of malware is now traveling as encrypted data also, and that only about 20% of organizations currently decrypt and scan the network traffic that is flowing through their system. As we become increasingly connected, our tablets, our cell phones, our computers, our IoT devices, our network traffic increases, which in turn increases the attack surface that is available to bad actors. So it is estimated that a ransomware attack occurs every 11 seconds and that the cost of cybercrime in 2021 was approximately $20 billion. So while TLS encryption is used by most legitimate network traffic, increasingly hackers are also using the same method to send malware. The TLS encryption, which is most often used, encrypts data sent over the internet using symmetric and asymmetric keys in a client-server handshake mechanism that just ensures that the communication that you're receiving is authentic, that it came from who it said it came from, and it has not been tampered with along the way. By doing this, your data is protected from unauthorized access. That means that private information like medical records, passwords, financial transactions are securely sent over the internet. Unfortunately, though, if hackers are sending their malware also through encrypted traffic and are able to actually deliver a payload to that hospital or website you use or bank server, then your data may be accessed anyway after it arrives at its destination, and then it's no longer secure. So looking at some of the different ways that you can machine learning could be used, you know, look at what they are. What's machine learning? What's deep learning? What's the difference? And so machine learning has been used to detect malware in recent years by several organizations, which we'll look at a little bit later. Machine learning uses algorithms on training and testing data that helps it to learn patterns that can be used in various tasks. Machine learning can produce models quickly. It can analyze large data sets much more quickly than human beings would be able to do. So basically, machine learning is getting computers to do something without them being explicitly programmed for each thing that they need to do. The contrast with deep learning is that deep learning structures algorithms in layers to create an artificial neural network that is inspired by brain functions. It still uses training and testing data, but it's more sort of based on how our brain's neural networking functions. They use these models to learn from the input data and to make intelligent decisions. Deep learning is a subset of machine learning, and both deep learning and machine learning fall under the broader category of artificial intelligence. But deep learning is usually what's really behind most of what, when we see like human-like artificial intelligence, that's mostly driven by deep learning. So these are some of the companies that have been using machine learning and their products that they're using, their respective products. So we have ExtraHop, which has Reveal X that uses out-of-band encryption. Darktrace has GA3, uses hash database. Cisco has Mercury, which has replaced Cisco Joy, which we'll talk a little bit about, and that uses feature extraction of network traffic. StealthWatch uses ETA or encrypted traffic analysis, which analyzes the network's metadata, and then Arista uses Awake, which uses fingerprint analysis, metadata stitching, and unique identifiers. They can make that just from combining different data. So as we move into our actual project, the analysis of our network traffic, we use curated data sets that were analyzed by Cisco Joy Telemetry. So those data sets had features that were pulled out before the data was encrypted so that it could be analyzed. There were two files, one a file of malicious network traffic, and the other one a file of harmless or benign network traffic. Those files were converted from JSON to CSV so that they could be in a data frame. And from those files, there was pre-processing, so duplicates were removed from both files. Also, null values were removed from both files. And then the files were combined. And so combined, those files was quite a bit of data. It was reduced to 38,000 rows so that the computation could move a little faster. And 130 of those columns originally in the data set contained null values. So once those were removed, we were down to 374 columns. From that data set, we split it. 80% was used for training and 20% was used for testing. And all the coding for this model was done in Python using Jupyter Notebook. So the main one that we were looking at, we did do 3 models, but the main one was the neural network. And so when the data was fed into the neural network, 2 hidden layers were used. And so ReLU was used as the activation function on the input layer and the hidden layer, and sigmoid was used on the output layer. The optimizer was atom, loss, binary, cross entropy, and metrics was used for accuracy. So this model we ran using various epochs to try to see what was the most accurate that we can get. So we ran it using 20 epochs, 30, 100, 150, and 200, and we reached the highest accuracy when 150 and 200 epochs was used, and that accuracy was pretty high, 0.9998. So total though, we ran 3 models, 2 machine, 1 deep learning. So we ran a random forest model, a logistic regression model, and neural network model. All 3 models actually gave very high levels of accuracy in detecting malicious traffic, but the neural network was the most accurate of the 3. So then moving into our last deliverable was the web interface. And so we used a software called Gradio to allow the data to be visualized and to be manipulated. So in that, you were able to choose the different input choices that you would want to have. And so our input was that you could choose your visualization. You could have a chart that showed accuracy of the neural network, or you could choose a chart that showed the loss. And then you would also be able to select from a list of files in a drop-down from a set of malicious files traffic and a set of benign file traffic for analysis. The output that you would get, of course, depending on what choice of output type you picked, was either a plot of the accuracy of the neural network cycles or a plot of the loss of the neural network cycles. And this is right now showing on this website URL using a Hugging Face integration. So this is a demo of the web interface. Some of the speed is increased during the process time because it did take a while for the process, considering the large amount of data and the number of epochs. So this is if you pick accuracy, this, and wait a little while. On average, it took about 15 seconds for each of the models to run, whether you were looking for accuracy or loss. And this is just a still shot of what you would see close up when you go to the web interface and how the accuracy model would come out. And this is where you would choose which type you wanted, and then where you would choose from your malicious file and your benign file. So overall, we feel good about our project. There, of course, were some challenges and lessons learned. It's difficult to coordinate diverse schedules of people who are working in families, but we were able to find our way to do so. The data collection for this, we had to use curated sets. It would have been nice or preferable to be able to do this on freshly captured data, but the Cisco Joy telemetry they used in the original is no longer supported. And there was a lot of work in those curated files that were beyond our level. So we just stuck with the curated files so that we could run a reliable model on them and feel good about the results. The steep learning curve for machine learning and deep learning, if you didn't take the practical data analytics class, and so there were only about 3 of us in the group, 2 who had taken it and 1 who was currently in it. And so this is very helpful and really necessary class for anyone to be able to understand how to run the the machine learning models. And then working with Gradio did provide some challenges for us in getting the web interface going, but we were able to work through and overcome that. So this is a chart of our overall work and time that we put into this program and the time that we spent. And then all of the different team member contributions. So Rima, Sabrina, Ashley, these are the different things that we contributed. And Victor and Santanu and Spencer, these are the different areas that they worked on throughout the project also. And so these are some of the next things we look forward to incorporating and getting finished. getting the feedback in from our sponsor and our final project package and final presentation, and then the reflection and the peer evaluation in our poster. So thank you very much for your time and for listening.